Thank you.
My name is Nelly Sayani, and I'll take you through how to create a box plot for male and female students age. So we are going to highlight the command for us to produce the box plot and execute. From the observation, the output female box plot, it is showing one outlier, which is for one outlier for female, and it is showing that the age of the female, which is the outlier, is 30, and for the male, there are four outliers, which are from 30, from 30 above. That is all for checking, for creating a box plot.
Pastor Theophilus Karua. I'll take you on OLS. So, first of all, we regress the hourly wage based on the schooling, marriage, and age as independent variables using the highlighted command. After regressing that, using that command, we commanded the R because it doesn't give us the summary of that regression using the command print summary or else model, because after commanding it with that command, it will give us the summary. So below is the summary of our OLS model. So to begin with, we can see that the p-value associated with k-square of the overall model is 2 point that number, which is less than 0.05 at 0.05 significant level, meaning to say it is significant. So coming inside the independent variable, we can see that schooling, it has 2.67992 coefficient, and its p-value is also less than 0.05, meaning that it significantly affects the dependent variables, which is hourly wage. So schooling, it affects the hourly wage by 3.67992 units. Marriage affects the dependent variable by 3.36317. And age, it affects the dependent variable, which is hourly wages, by 0.2777, meaning to say 1 unit increase in those independent variables, it affects the independent variable by those figures: 3.36, 2.67, and 0.277. Thank you so much.
My name is Faith Milongo, and I'll take you through the diagnostic tests. And I'll take you through the first diagnostic test, which is checking for mitochondriality. So as you can see on the screen, the highlighted code is the one which we are going to use for checking mitochondriality in our data, which is school, married, and age. So below is the results for each data. The first data shows that the VIF is 1.017, which means that it is less than 10, which means there is no matrimoniality in school. And the second VIF mean shows that it's also less than 10, which means that in marriage there is also no matrimoniality. And the last data also shows the VIF, which is less than 10 as well, meaning that there is no matrimoniality in all the data. Thank you.
Next slide, Moni. So I'm going to take you through on another diagnostic test, which is heteroscedasticity. And on this one, we use the highlighted code and execute it. Yeah, so our p-value is 0, which is less than 0.05. So we reject the null hypothesis and conclude that there is a problem of heteroscedasticity. Yeah, that's it.
My name is Rukaya Usman. I will explain on the last diagnostic test which we learned on our group, which is autocorrelation. So first of all, we learn to command DW statistics. So our results is 1.527, which is less than 2, meaning to say this model has no problem of correlation.
My name is Absent Chambari, so I'm going to take you through the process on how to learn a logistic regression to predict birth weight based on age of the mother, race, and smoking during pregnancy using the LBW dataset. So we had to run the logistic regression called the legit model. So that's it. We are regressing on the row that is based on the weight that is less than 2,500 in grams for the birth weight. So based on that, as you can see, we have got 189 observation, that is the lows, and 11 columns. So based on the regression of birth weight based on the race, age, and smoke, now you can see the results below in the output, whereby we have an intercept which is of negative 1.39051, and when we check on the race, we have a positive coefficient of 0.52910. Then we check on age, it has a negative value on the coefficient estimate. So the last one is the smoke. Okay, yeah, so that was network problem. So we are, as you can see on smoke, we have a coefficient of 1.095. Yeah, that's it. So when we check the p values, we will see that it is less, it is significant at 0.05, and the other variable which is significant is the smoke, which is significant at 0.05. So the next thing, we are going to run the calculation of the marginal effect to see how variables that are significant, that is the race and smoke, how do they affect the birth weight during pregnancy. Thank you so much.
My name is Yamike Mandara. I will take you through how to calculate marginal effect. And to execute the marginal effect, we use the highlighted command as shown on the screen, and these are the results that we have been given. So according to our dy and dx results, we can see that it's only race and smoke that are significant at 5%, and showing that a unit change in race affects birth weight positively by 0.10511, and a unit change in smoke affects birth weight by 0.22 407 units. Okay.
I'm name is Nanchiseo, and I'm taking you through on the Flowbit model. Yeah, first thing we install the package, and the package is like margins. And step 2, we load the auto dataset, as you can see. Then we check for the dependent variable. For us, we are given our dependent variable to be the foreign, the origin of the colors. So we choose foreign as independent dependent variable, and our independent variable we are given that we should use with the weight and the mileage, which is MPG on the probability model. So we learn the probability model. We use this command probability model. Probability model GLM foreign. We start with foreign, then weight plus what plus the MPG, the data auto, the formula. Display the result. That we commanded the R to produce the results of probability model, so that we can see the coefficient table. Here are the results. Restoring the package shows that the package was stored from the drive. This is the path for the drive. Then we load all the data set. The data loaded successfully. It shows. Then we command the R to show all variables, and these are variables. But in our case, we have given the foreign as our dependent variable, and MPG, which is mileage, and the weight as our independent variable. So the dependent variable that we indicated is a foreign, unique values for foreign. It shows that 1, 2, 0, 1, 52, 2, 2. The probability model results shows the coefficient estimated standard error, Z value, and P values. These are the coefficients.
Mr. Banda, I want to give you the summary of what we did. Number one, we first load the student data and we check the vacancy, the box on this seat. And then we load another data, wage one data, and learn OLS. We did diagnostic testing. We also learned probability using auto data.